Hello. In this video, we'll learn about computer organization, architecture, and software systems. And this is a beginner guide on computer organization, architecture, and software systems. This presentation aims to demystify the inner working of computers by exploring how hardware components and software collaborate to create functional systems. Understanding these fundamentals helps you grasp how computers execute tasks efficiently, paving the way for deeper learning in computing and programming. We will journey through the physical makeup of computers, architecture, design, philosophies, how instructions are processed, and the vital role software plays in managing hardware resources. Let's dive into the heart of the computing technology. Computer organizes the physical components. I like if we take the focus on how various physical components connect, work together inside the machine. Key parts include the central processing unit. It's called CPU, memory modules, storage device like SSD or hard drivers, and input-output interface such as USB ports. The backbone that ties these components is the system bus, consisting of data, address, and control buses. These buses are responsible for transferring instruction and information among components. Motherboard layout. CPU circuit centrally located for processing power, memory slots arranged for optimal speed and access. Expansion slots and connectors for peripherals, power security integrated for efficient energy delivery. Computer architecture designing the blueprint. The first is instruction set architecture, CPU components, memory hierarchy, architecture models. And instruction cycle fetch decode. Fetch, decode, execute. Fetch is the process returns an instruction from memory based on the program counter's address. Decode, the control unit interrupts the fetch instruction to determine the required operation and operands. Execute, the ALU performance performs the specified operation such as arithmetic or logic, affecting registers or memory. For example, a simple addition instruction would fetch the operands, decode the addition operation, and then perform the computation, updating the result register accordingly. Memory management organizing data, RAM, memory, memory addressing, program allocation. If you take the RAM volatile, memory storing data temporarily for active programs and process enabling quick access. Virtual memory extends memory by using hard drive spaces, allowing larger programs to run than physical memory alone permits. Memory addressing, the CPU uses addresses to locate data in memory, ensuring efficient access and execution. Program allocation is operating system allocate memory space strategically to optimize usage and prevent conflicts between programs. And next is software system, the operating system OS, kernel, file system. Popular OS example include Windows, Mac OS, Linux, each which unique architecture design suited for different user needs. And an input output interact with the world. IO device hardware such as keyboard, mouse, displays, and printers allow us user to input data and receive output. Device drivers, special software modules that enable the operating system to communicate and control hardware devices properly. IO methods, polling CPU activity checks, device status, interrupts device signal CPU when it attaches needed. DMA direct memory access allows device to transfer data directly to memory. For instance, pressing a key on the keyboard triggers a series of signals and processing steps, ultimately displaying the corresponding character on the screen seamlessly. And the conclusion, the harmony of hardware and software. Foundation of computing, understanding computer organization and architecture gives insight into the physical and logical structure of computing machines. Role of software systems. Software brings hardware components to life, enabling complex tasks, resource management, and user interaction. Empowerment through knowledge. Grasping these concepts lays the groundwork for more effective programming and deeper engagement with computing technology. Together, hardware organization and software work in tandem to create powerful, efficient, and versatile computing platforms that shape our digital world. And that's all for my way for now. Thank you very much.